Okay, this is the easiest way to interpret position versus time graphs. So let's start with just a random position versus time graph. Okay, something like that. You're going to be asked a lot of questions about this. When is it moving? So this is a position versus time graph, first of all. Remember that you need to be clear on whether a curve like this is a position versus time graph representing a one-dimensional motion or the path of an object in 2 dimensions. Okay, they mean totally different things. But if you see something like this and it says it's a position versus time graph, you're going to be asked when the object is moving in the positive direction, when it's moving in the negative direction, that kind of thing. And always, I think the easiest way to deal with this is, okay, so we'll first mark the beginning and end points. And then the first step that you want to take is you want to find all the spots where the slope of the tangent line switches from positive to negative or negative to positive. Okay, so you can see here, like if you draw the tangent lines there, okay, the slopes of those tangent lines change, but they're all negative. At this point here, the slope of that tangent line is horizontal. And for anything before that instant, the slopes of the tangents would be negative. For anything after, they would be positive. And so mark this point. Mark the points where the slope of the tangent changes signs. It's always going to be at a point where the tangent is horizontal or has a 0 slope. So, okay, those are the 2 places. I mean, maybe you could argue somewhere here too. That's just the way I drew it. I guess let's do that, sure. Okay, so those are all the places where the velocity changes sign, where the slope of the tangent changes sign. Now, find all the places. This is maybe a little trickier, but the second step is to find all the places where the concavity changes sign. So notice that along this part, it's concave up. Somewhere around here it switches and now it's concave down. Okay, and you don't have to be super picky, but identify a point in there where it goes from concave up to concave down. And here it's concave down, here it's concave up. I don't know where it switches, but maybe somewhere around there, okay? So now we've found all the places where the velocity changes signs and the acceleration changes signs. And now you have a bunch of intervals. Between the first 2 dots is one interval. Between dot 2 and 3 is another one. 3 and 4 is another one. And on each of these, what that means is that the sign of the velocity and the sign of the acceleration are constant between dots. So let's identify what the signs of the velocity and acceleration are between these dots. The slopes of the tangents are negative between these first 2. So here we have a negative velocity. It's concave up, so we have a positive acceleration. Between these 2, we have a positive velocity and a positive acceleration because it's concave up. Between these 2, the slope of the tangent is positive, so that's a positive velocity. It's concave down, so that's a negative acceleration. Between these 2, pause the video for a second and see if you can identify the signs of the velocity and acceleration between those next 2. Okay, well, the slopes of the tangent lines are negative, so that's a negative velocity. It's concave down, so that's a negative acceleration. How about between these two? Pause the video for a second and see if you can identify the signs of those. The slopes of the tangents are negative. It's concave up, so the acceleration is positive. And then this one, I don't know, it looks like a straight line to me, so let's call that, the velocity is slightly positive. Let's call that a positive velocity. And since if we think of that as a straight line between those two, then the acceleration there is going to be equal to 0. Okay, so now what can you do with these? Well, now, if the question asks you where the object is moving in the positive direction, you're just going to look for all the places where the velocity is positive. So it's moving in the positive direction here, here, and at the end, in that last interval. It's moving in the negative direction between these two, these two, and, no, not the last one, but just from here to here. And then, where is the acceleration positive? Acceleration positive all the way from this first dot to the third dot, because you see the accelerations there. Acceleration is positive again from this dot to this dot. And what about speeding up and slowing down? Well, remember that an object is speeding up if velocity and acceleration have the same sign, and it's slowing down if velocity and acceleration have opposite signs. So it's slowing down between the first two dots, speeding up between dots 2 and 3, slowing down between 3 and 4, speeding up now in the negative direction between 4 and 5, slowing down, and then this one, since acceleration is 0, it's not changing speed there. So I think that's the best way whenever you're asked to look at a position versus time graph and figure out, where the acceleration is negative, where the thing is moving in the positive direction, where it's slowing down. First, draw out these dots, identify those places where the velocity and acceleration change signs. Then on the intervals between the dots, figure out the signs of the velocity and acceleration. And then once you do that, all of the rest of the answers just follow really quickly.